Okay, this is a pretty simple problem, or at least it sounds simple. The question is, if you have a block and you're holding the block against the wall, how much horizontal force do you have to apply to hold the block against the wall? So the key here is realizing that if we draw the free body diagram, there's a downward force of gravity, which means there must also be an upward force, and that's not the force that you're applying. That must be the force of friction. So what you're applying on the block is some amount of force that you choose, which means you are changing the normal force. So there's actually 4 forces on this block, and it's not you that's holding the block up, although we say that in English, but it's the friction that's holding the block up. So before you try and sort of, shoot from the hip here, let's word the problem this way. Let's find the minimum force, which is another way of saying maximum static friction. So what we have then is we'll choose axes, and we'll choose X and Y, and we'll write down the sum of the forces in the X direction, which is your pushing force, and the normal force goes in the other direction. Oops. Your normal force goes in the other direction. That has to equal 0, and the sum of the forces in the Y direction, there's a force of friction, which is mu S times the normal force minus Fg. Why mu S times the normal force? Because that's the maximum static friction. Okay, that also equals 0 then in the Y direction. So that means we can combine both of these equations. We solve the top one for Fn, which says that Fn equals how hard you're pushing, and then we plug that back into the bottom equation, and we get that mu S times F minus Fg equals 0. So F is equal to Fg divided by mu S, or mg divided by mu S. So for example, if mu S is 0.5, you have to apply a force that's twice the weight. And if it's really slippery, so that mu S is 0.1, you have to apply a force that's 10 times the weight. In fact, because mu S is less than 1, this is greater than mg. So there you go. That's the answer.